Massage chairs are among the strangest and most paradoxical machines of modern life. Some of them can weigh more than 180 pounds, contain dozens of motors, nearly 50-inch long steel tracks, and generate enough mechanical force to reach deep into human muscles. Yet their ultimate purpose is simply to create a feeling of comfort and relaxation. Hidden beneath the soft cushioning is a complex electromechanical system made up of motors, pneumatic airbags, and robotic mechanisms engineered to replicate the movements of human hands. To keep that entire system operating smoothly for years, everything, from the load-bearing steel frame to the continuously moving mechanical assemblies, must be manufactured with extremely high durability and precision. In this video, the Factorin takes you inside the complete manufacturing process behind one of the most sophisticated relaxation machines ever created for the modern home. Few people realize that the origins of modern massage chairs can be traced back to massive mechanical therapy devices that appeared in the late 19th century. At the time, many hospitals across Europe and the United States used vibrating machines powered by flywheels and electric motors to stimulate blood circulation and relieve muscle pain for patients. But more than a century later, the technology has evolved into a global industry worth over $4 billion, with tens of millions of units sold every year. What has driven this industry to grow so rapidly is the simple fact that modern humans now spend most of their lives sitting in offices, inside cars, and even on airplane seats. According to multiple studies, the average adult can spend more than 9 hours sitting each day, dramatically increasing the global demand for muscle recovery and body pressure relief. As a result, massage chairs are no longer seen as luxury products designed only for older people. They are rapidly becoming one of the fastest growing technologies in the modern wellness and personal healthcare industry. Hidden beneath the outer leather in the complex massage system is a load-bearing frame built from massive industrial steel bars and tubes weighing thousands of pounds. Inside the metalworking plant, molten steel is continuously pressed through gigantic rolling mills to form long metal structures with uniform thickness and high load-bearing strength. Some high-end massage chair models use steel thicker than 2 millimeters in order to support loads exceeding 300 pounds over years of continuous operation. Once cooled, the steel components are fed through automated cutting systems, where they are divided into precise sections for the base frame, backrest structure, and support mounts for the massage mechanism. Next, CNC laser cutting machines begin processing each component with extremely clean cuts in preparation for the welding stage. Automated welding robots continuously rotate, clamp, and weld the connection points to assemble the complete frame structure. The frame and load-bearing assembly alone can weigh more than 80 pounds before the motors and outer panels are even installed. Finally, workers use electronic torque guns to secure every joint to preset specifications, transforming separate steel components into a rigid skeleton capable of supporting the entire massage system behind it. Before assembly begins, the steel bars and tubes are fed through shaping systems to create the curves needed for the backrest and the internal load-bearing structure. Automated welding robots then continuously clamp and weld the connection points, forming a rigid frame strong enough to support the entire massage system behind it. Once the frame is complete, the production line begins installing the most important part of the chair, the mechanical massage system. Workers place each motor into position and connect them to the sliding rails, gearbox, and roller assemblies. Each motor is responsible for a different movement, from pulling the rail system up and down to controlling the kneading and compression motions. In high-end models, more than 20 motors can operate together at the same time to create dozens of massage modes. Long rail tracks are carefully aligned along the backrest before the roller assemblies are installed and manually tested. During a single 15-minute massage session, the system can generate thousands of small, continuous movements. The challenge is not just creating strong pressure, but making every movement smooth and precise enough to feel like real human hands. While the mechanical system is being assembled, another production line is forming the plastic outer shell of the massage chair using vacuum forming technology. Flat plastic sheets are heated until soft. Then powerful suction pulls them tightly against metal molds to create armrests, side panels, and leg massage covers. In less than a minute, a flat sheet is transformed into a finished component before robots trim the excess edges and drill the necessary assembly openings. Once the steel frame and the entire massage mechanism are complete, the chair is still nothing more than a rough mechanical machine. The stage that truly begins transforming it into a premium product is the upholstery and surface finishing process. The part users will see and touch every single day. Large rolls of synthetic leather or genuine leather are laid flat across automated CNC cutting tables. A positioning camera system quickly scans the entire material surface before the cutting blade begins moving according to pre-programmed design files. Within minutes, dozens of different leather pieces for the backrest, seat cushion, armrests, and leg massage modules are cut with tolerances measured in mere millimeters. Right beside them, high-density foam blocks are also fed into separate cutting machines to create cushioning zones with different firmness levels. Next, workers begin feeding each leather piece into high-speed industrial sewing machines. Rows of needles continuously drive downward at thousands of stitches per minute to create long, straight, and perfectly even seams. A single complete upholstery set can require more than 1,000 inches of stitching running across the entire chair. In premium models, the stitching does more than simply hold materials together. It also shapes the surface and enhances the luxurious appearance of the chair. Once the upholstery is finished, the most difficult stage truly begins. Workers must manually stretch each section of leather and press it tightly against the cushioning beneath before securing it with industrial staple guns. Hundreds of metal staples are continuously fired into the underside of the frame to keep the leather perfectly tight across the chair's complex curved surfaces. Even a slightly uneven pull or a single small wrinkle can force the entire upholstery section to be removed and redone from the beginning. Inside another section of the factory, the electronics production line begins building the brain that controls the entire massage chair. Blank PCB boards continuously move through high-speed SMT assembly lines, where robotic pick-and-place arms operate almost non-stop. Resistors, capacitors, processors, and microchips are placed onto the board surface at extremely high speed and with precision measured in fractions of a millimeter. Some modern SMT machines can mount more than 30,000 components per hour, so fast that to the naked eye, the robot heads appear as nothing more than continuous blurred motion. Once assembly is complete, the boards pass through reflow ovens operating at temperatures above 450 degrees Fahrenheit, melting the ultra-thin solder beneath each chip to permanently secure every component in place. AI-powered inspection cameras then scan every tiny solder joint to detect misalignment or incomplete connections that would be nearly impossible for the human eye to spot. Before leaving the line, technicians upload the control software directly into the boards. This system will ultimately process thousands of signals every second to control massage pressure, vibration intensity, airbags, speakers, sensors, and every movement of the chair. Once the control boards are complete, the chair begins coming together as a fully integrated electronic system. The power supply unit is installed into the body of the chair before bundles of wiring are routed throughout the frame to connect the motors, sensors, airbags, control panels, and Bluetooth speakers. In high-end models, the total length of internal wiring can exceed 100 feet, yet every cable must be carefully organized and secured away from continuously moving mechanisms. Electrical connectors are plugged in according to color-coded markings to reduce assembly errors, while each wire bundle is fastened with plastic clips to minimize vibration, friction, and hidden wire damage after years of use. Once the entire mechanical and electronic system has been installed inside, the production line begins attaching the foot massage module, packed with multiple airbags, extension motors, and massage rollers, to the main body of the chair. In high-end models, the footrest can automatically extend by more than 6 inches to accommodate users of different heights before being fully connected to the central control system. The chair then moves into the final outer body assembly stage. Workers position large plastic panels along both sides of the chair, carefully align each edge, and secure them tightly to the steel frame using powered screw guns. Next, the back cushions, seat cushions, armrests, and exterior components are installed one by one to form the chair's final shape. In models priced above $15,000, the gaps between panel joints are sometimes allowed less than 1 millimeter of variation. Workers manually inspect the firmness of the armrests, the tension of the upholstery, and the alignment between plastic panels to prevent vibration or unwanted noise during operation. The outer shell also helps reduce the sound produced by more than 20 motors running continuously inside the chair. Before leaving the factory, every massage chair must go through a final inspection stage with a series of tests designed to simulate real-world use. Technicians activate each function one by one, including back massage, foot massage, airbags, heating, Bluetooth speakers, and stretching modes, carefully monitoring the stability of every movement. Once the entire system is operating reliably, the massage chair is finally moved to the packaging area in preparation for shipment. Due to their large size and weight, which can exceed 250 pounds, many models must have the armrest or footrest assembly removed to reduce package volume and minimize damage during long-distance transportation. Workers wrap thick layers of protective foam around the chair, add extra protective panels to impact-prone corners, and secure the entire product inside oversized cardboard cartons. Automated sealing robots continuously tape and seal each package before barcodes are scanned to store the full product information. Today, some large factories are capable of shipping thousands of massage chairs every day to showrooms, hotels, and homes around the world.